The two components connected in parallel, the probabilities of survival reliability are of the components making up the system are given below. So you got two components, one is the R1, the other one is R2, and the rate of reliability is basically 0.92. So what it means, the reliability can maximum be 1, and for two components it's given as 0.92 and 0.85, and it's basically a parallel system where you got two resistors R1, R2, as you can see in this graphic. The system works if either one of the parallel components functions. The reliability of the system in its parallel combination is. Now there could be multiple ways of doing something like this. I'll try to explain in a simplest way I can. Like I mentioned earlier, the reliability at most can have a maximum value of 1, right? So let's just find out the non-reliability of this individual components. So for the resistor R1, the non-reliability would mean 1 minus 0.92, which gives us 0.08, right? This is the non-reliability rate or the probability of a component being non-reliable, correct? Similarly, for resistor R2, we're going to subtract 1 minus 0.85, and that gives us 0.15. Now, we don't stop here because our goal is to find the reliability of this system in its parallel combination, correct? So how do we do that? For the whole system, again, the maximum reliability you can get is 1, correct? And if we can subtract the non-reliability of the two product of the two non-reliability probability that we got, if we can multiply that and subtract the product of that from 1, we will basically get the reliability rate of the system. So let's just plug in the values here. 1 minus 0.08 times 0.15, and reason we are basically taking a product here is because we want to find the reliability of the combined system, which is a combination of R1 and R2, correct? So if you do the math here, you will basically get 0.988. So the reliability of system is extremely high, 0.988. It can also be written as 98.8%, extremely high.